All right, so this is just a continuation. Um, so the planets Uranus and Neptune are gas giants as well. This, of course, is Neptune. One thing that was particularly surprising about Neptune is they actually call this the Great Dark Spot, similar to Jupiter's Great Red Spot, of course. Here, let's maximize this. Similar to Jupiter's Great Red Spot because it's a storm. What else? Probably, yeah. The planet Uranus is its axis is tilted to 90 degrees roughly to the ecliptic in the plane of the solar system. That's something we find interesting about Uranus. It's also, of course, the first planet that was discovered with a telescope, and then about a generation later, Neptune was discovered. It was in the early 1800s, Neptune. Let's see, comets and asteroids. All right, so obviously there are other things in the solar system, and as they say here, these are basically leftover things that didn't go into planet formation. And there might be quite a substantial amount of this stuff. We really still don't know entirely. We do know, however, for example, if you look at this picture right here, this is a very famous photograph of Jupiter, the surface of Jupiter, being hit in 1994 by the comet Shoemaker-Levy 9. Before it hit, we weren't exactly sure what was going to happen, whether we'd even notice it or not. But this mark, or these marks, there were several marks, as this comet broke apart as it approached Jupiter. They stayed for several months, actually. You could still see where Jupiter had been hit by the comet. And back in the 1990s, or really before that, people really didn't think that there was a lot of collisions going on, especially in modern times. But this proved everyone wrong. Now, where do the comets come from? There's a region that surrounds the solar system, a proposed region, mind you. It's nobody knows exactly, how far out it goes. As some people have proposed, it goes 1,000 astronomical units. Remember, an astronomical unit is the distance between the Earth and the Sun. So this region is called the Oort cloud, and Oort was the one who first proposed this. And I want to make sure that this is clear. No one's ever seen the Oort cloud. It makes a lot of sense that it's there. Someday we may send space probes out there to investigate it. But it is almost certainly there, because what it does is it explains a lot about the comets, about what, how we see, if you imagine the plane of the solar system, we see comets coming in at all sorts of angles, and they have highly elliptical orbits, extremely elliptical orbits, and they also, the comets that come from way out here have very long period orbits. So some of these things can have orbits of thousands of years, so that it takes thousands of years to complete one orbit around the sun. And as the solar system goes around, travels through the galaxy, we think that sometimes these comets get a gentle nudge, a gravitational nudge from some relatively close by star. Anyhow, what are comets? One proposed idea back in at least 50 years ago, more than that actually, is that they were basically dirty snowballs. They had dirt, obviously, and they were just frozen water. In recent years, we've sent spacecraft to comets and passing through their tail, and it turns out that they are frozen water, frozen carbon dioxide, and also frozen ammonia and frozen methane, with little bits of dust and rock. The comet has a very solid area, and that's generally called the coma, or the nucleus. The coma is the gaseous region around the nucleus of the comet, and its tail will always point. The tail of the comet always points away from the sun. So even when it swings around the sun, the comet can be moving in one direction and its tail pointed in another direction. So the tail isn't always streaming behind the comet. Let's see, asteroids. Of course, the main belt is between Mars and Jupiter. There are an enormous number of asteroids there, but it's not like you see in the movies. Like, one thing that it definitely has people confused is movies like Star Wars, when they're moving through an asteroid belt. If you were to pass through this asteroid belt, let's say you went close to one particular asteroid, I mean, you did that on purpose, you wouldn't see any other asteroids anywhere near you. It's that spaced out. It's not, they're not like on top of each other. There are stony asteroids. There are ones that are very rich in carbon, and then there's actually metallic ones, which tend to be mostly iron and nickel. We believe that these are leftovers, essentially, from the formation of the solar system itself. And the other thing is that Jupiter's gravity is so great. Remember, it's the largest planet, of course. It's so great that it basically prevents these asteroids from clumping into larger things. Remember, Ceres is the largest of the asteroids. It's actually, now that we redefined what a planet is and what a dwarf planet is, it actually now has the designation of a dwarf planet. So it's large enough to be circular. A lot of the asteroids are not. They're too small. Anyhow, let's keep moving here. Meteors. Okay. So here's a very the meteors have three different definitions. Okay, so a meteoroid is anything that is traveling in space. Okay, the debris field from a comet or from an asteroid that, as it passes by. One thing I didn't mention is, like, for example, what's going on with comets as they approach the sun is that ice, the water ice, the methane ice, the ammonia ice, whatever, carbon dioxide ice, is sublimating, it going directly from a solid to a gas, and that's what the tail is. That's what you see, and the Earth sometimes passes through that. And a lot of times what you'll see is when that debris hits the Earth, that's what a meteor is. That's, some people, when you were a kid, probably they called those shooting stars. It's nothing to do with stars. This is all within our solar system, of course. And so as soon as it hits the atmosphere, you have that's called a meteor. Some of them are particularly bright. They streak across the night sky, and all that is the friction between the debris material, whether it's comet material or asteroid material, and the atmosphere. And occasionally, we actually know there are certain times of year where the Earth consistently passes through one of these different debris fields, and here are the names of the different. They're called meteor showers, and we know exactly when they take place. For example, the Perseid meteor shower is often a very nice meteor shower in the summer. Of course, if the moon isn't in the way. And the Leonid meteor shower is a really good one as well. All right. Anyhow, so that's what a meteor is. Remember, meteoroids are just anything in space that is just that the Earth could run into. A meteor is just something that actually hits the atmosphere, and then a meteorite which is a much rarer thing, because of course the Earth's atmosphere has a lot of friction and would generally break up these meteors into, until they completely vaporize. But a meteorite is something which is generally made of iron or very, very hard stone, where it'll actually hit the Earth. It'll hit the surface of the Earth, and these things have been collected over the years, and some of them are quite valuable. They'll actually have some rare earth metals and things like that. All right, there's some pictures of them. The origins of the solar system. So the first thing is to understand that the solar system formed from these gigantic clouds that we find between the stars, and they're still there. There's lots of them in our galaxy. When we look around, within the Milky Way galaxy, we find what are called interstellar gas clouds, mostly composed of hydrogen and helium. But occasionally near these things, a dying star will end its life in a tremendous explosion called a supernova. And the normal thing that for most stars, when they die, are not massive enough to become supernovas, and those stars will create from hydrogen and helium all the way up to iron, the element iron. But these larger stars, when they go supernova, they'll create the rest of the periodic table, so all the way up to uranium, element 92, the last naturally occurring element. And what we realize, of course, is our solar system, which, you look at the sun, and the sun has about 2% of its mass made of heavier elements, heavier than hydrogen and helium. Therefore, we know that there must have been a supernova that created those elements, and that spread to the original interstellar gas cloud, and then that gas cloud collapsed and began, as it collapsed, it was of course moving in a circle. And really, after that, physics takes over, and we understand that, for example, when just like when an ice skater is spinning, and she pulls her arms in, she will begin to spin faster, and that's called the conservation of momentum. It's the same thing that happens with these gas clouds. As they contract and they're spinning, they start to spin faster and faster, and more material ends up at the center. Let's see. Before there's an actual star formed, for stars to exist, there has to be a conversion of hydrogen into helium. That's the energy source of all the stars. And before that, that's called a protostar. These are found within our galaxy and other galaxies as well. And basically, they're hot just because material is falling into them. And the star, eventually enough material falls in so that it's superheated at the very center, and hydrogen turns into helium. That's called fusion. So when that takes place, a star is born. This is going back to, so that's the origins of the solar system. This is going back to the solar system that, you go back to the time of the Greeks. There were different ideas. Of course, they thought that the Earth was the center of the solar system, and all the other planets went around. The problem with that is that if you just sit there and you observe a planet, there's a time in its orbit as it's moving that it'll move backwards or westward in the night sky. And this isn't something you see overnight. It takes weeks to months to actually see this. And then the Greeks could not explain, why would a planet that's everything's orbiting the Earth, why would it suddenly move backwards? And of course, Copernicus fixed this by saying, okay, it's just an optical illusion. The planet never changes direction. It's just one planet overtaking another in its orbit.